Chad Hanson. He's going to talk about the giant sequoia and high intensity fire revisited. He's going to review the relationship between giant sequoias and high intensity fire. Currently, disinformation about this relationship is being used as the primary political talking point to promote destructive logging measures and environmental rollbacks. Dr. Chad Hanson is a research ecologist and the director of John Muir Project of Earth Island Institute. Dr. Hanson has a PhD in ecology from the University of California in Davis, with a research focus on fire ecology and fire and conifer forest ecosystems. Dr. Hanson, please take it away.
Thanks, everybody. Great to talk to you again. I'm going to share my screen here. Let's see. It's not coming up the right way. Let's see. Okay, here we go. All right, that should work. All right, so can folks see my screen? All right, good deal. So let me expand that image. All right, so I'm going to be talking about giant sequoias and fire today again, but today I'm going to focus very specifically on high intensity fire. And the reason I'm going to do that is this. The last time I talked to you all about giant sequoias and fire, we had published, fairly recently at that time, 2 scientific studies, me and my research partners, some of whom you know. And what we found is that the giant sequoia regeneration was the best. It was the densest, growing the fastest, the most vigorous in the areas that actually burned at high intensity. And so the evidence pointed to the conclusion that giant sequoias are actually associated positively, not just with fire, but with high intensity fire. The narrative coming from the land management agencies at that time, the Forest Service and the Park Service, and U.S. Geological Survey, that narrative was that giant sequoias need fire, yes, but they need low intensity creeping surface fire. What we found is that there's very little regeneration that survives or grows with any significant speed. It's whatever survives is very stunted in those low intensity areas. Where you get the regeneration is at the higher intensity areas where the flames go high and they kill most or all the trees. So this is a habitat type that evolved over millions of years, and there's many different plant and animal species that depend specifically on the habitat created by high intensity fire. It appears that giant sequoia is one of them. Since we published our studies, the land management agencies have said, okay, fine, we concede the point, giant sequoias are really associated with high intensity fire, but they said just not big patches and not at the high end of high intensity. In other words, they think that giant sequoias only regenerate well with small patches, fractions of an acre, that's really high intensity surface fire, but the flames don't reach very high. And they really can't regenerate in crown fire patches, especially large crown fire patches at that upper end of high intensity. So that's what we have been investigating this year in 2025. And what we're finding is that that is not the case at all. We're finding something that's dramatically at odds with that narrative coming from the agencies. And let's give you a little bit of background here before I go into the first slides. Their big focus is the 2 big fire years from 2020 and 2021. A number of natural lightning fires burned through most of the groves in those 2 years, in 3 different fires. And a lot of people misunderstand those fires, thinking that there's a lot of hyperbole out there, thinking that it's mostly high intensity fire. Those fires were 87% low and moderate intensity surface fire, and 13% high intensity fire. And even the high intensity, only a portion of that was large crown fire patches. So that's what we wanted to focus on. Is it true that they really don't regenerate in large crown fire patches, and they only regenerate, they regenerate best in high intensity, but only in tiny patches at the low end of high intensity? All right, so here we go. This is common. This is pretty typical of what you will see in these large crown fire patches. This is in the Freeman Creek Grove. This is in the largest high-intensity fire patch. This is a crown fire area deep within the crown fire patch. And these are all giant sequoias. These are just for perspective, these are between 6 and 8 feet tall. And I took this picture this past summer, 5 years post-fire. And this is what's going on. This is all natural regeneration. I took this picture just a few weeks ago. This is the Redwood Mountain Grove. This is also a crown fire area. It's deep within the large crown fire patch on the southern end of Redwood Mountain Grove, part of that 13% that burned more intensely. And this is where you see the dramatic regeneration. That's almost all of that is giant sequoia seedlings and saplings. And they're all ages. It's interesting, this is 4 years post-fire in this particular fire. Some of these are 8 or 10 inches tall, and they just came in last year. And some of them are just a few inches tall, and they came in 2025. And others are 5, 6 feet tall or taller, and they grew in 1 year post-fire, which was 2022. But there are tens of thousands per acre, tens of thousands. Dramatic, dramatic regeneration. And you can see for scale here, this is back to Freeman Creek Grove in the Crown Fire Patch. That's Jen Momola from JMP. And this was a site visit we did earlier this summer. This was in June. And you can just see how dramatically those trees, these giant sequoias, have grown in just 5 years after the fire, after this Crown Fire Patch. And interestingly, even in areas of 100% montane chaparral cover, 100% cover of these native shrubs that are natural fire followers after high intensity fire, you see dramatic giant sequoia regeneration. Now, you may not see it at first glance, and this is part of the problem. People walk by these areas, and if they're not looking closely, they'll miss them, which is why I overlaid circles here. There you go. So you can see that those are all giant sequoias, and in many cases, 3 or 4 giant sequoia saplings in each of these circles. These are about 6, 7 feet tall. This is at 4 years post-fire. So in other words, at 4 years post-fire, these are a maximum of 3 years old, and some of them were already 6 to 7 feet tall. We found some that were already almost 8 feet tall. And so they are not impeded by shrub cover. This is one of the narratives, that they can't regenerate in large crown fire patches, that the cones will be incinerated and the seeds will be incinerated along with them. Therefore, there's no potential for regeneration. The trees are all killed. There's no live trees within hundreds and hundreds of meters. This is the narrative. And then if there is any germination of sequoia seedlings, the shrubs will kill them. Giant sequoias are not having any trouble whatsoever with shrub cover. And it's not this dense in many places, but it is in some places. You do have 90, 95, 100% native shrub cover, which is natural in high intensity fire patches. But the point is, we are not seeing a negative relationship with high severity, with giant sequoia regeneration. And this is what it looks like on the tops of these crowns of giant sequoia snags, these larger giant sequoia snags in these crown fire patches. They have hundreds and hundreds of cones still on them at 5 years post-fire, 4 years post-fire, literally hundreds. And so this notion that somehow these crown fire patches incinerate the cones, incinerate the seeds, that's just simply not happening. It was an interesting hypothesis that some of the government scientists put out there, some of the agencies put out there, but it is not what's happening. And again, this one here, and this is just a portion of the crown that I zoomed in on here, or it's actually a colleague of mine, Craig Swalgard, took this picture. Zoomed in on this, and but you can see, these tight clusters of cones clinging to these branches of these large giant sequoia snags, hundreds and hundreds of them. It's just remarkable. And this is 5 years post-fire, this snag here. Now, here's the other thing that's happening, is that the land management agencies underestimated what happens with giant sequoias in these large crown fire patches. It is not 100% mortality. It's actually closer to about 20% survival of the large giant sequoias. It's very, very high survival in the low and moderate intensity areas, but in these high intensity patches, even in the crown fire patches, a certain percentage of them survive, but they don't look like they're alive initially, many of them. They produce new green foliage the year after the fire and in every subsequent year through what we call epicormic branching. So in other words, some of these giant sequoias, some of these big giant sequoias that look like they're dead immediately after the fire, and even in the first spring after the fire, start to produce new green foliage in the first summer, in the first year post-fire, and in every subsequent year, and you just get more and more green foliage. And this is an example of that right here, that green on top and on the side branches. That's all from epicormic branching. Another example here, you've got sequoias, especially in the center of the image there. That one on the upper right probably retained green crown, but the others, they would have looked dead right after the fire. That's all new production of green foliage from epicormic branching after the fire. Here's another example here. In this one, unless you look really closely, it looks like a snag, but then you look and you see on the top right, it's producing all new green foliage. I took this picture this summer. This is in the Redwood Mountain Grove in the large high-intensity fire patch. So that is all at the ends of those branches. That is all production of new green foliage, new branch structure, new green foliage that's producing photosynthesis for that tree. This is a live tree. Just didn't look alive. And so the point is that there's actually a lot more live sequoias scattered throughout the interior of these large high-intensity fire patches, even these crown fire patches, than people first realized. And what we're finding is that the regeneration is extraordinary. So not only is there potential for more regeneration in the future because there's more surviving trees than were initially thought to be the case, but also the natural regeneration that we found, for example, in Redwood Mountain Grove, in the large high-intensity fire patch, is 4 times higher than the land management agencies projected for 4 years post-fire, and it's twice as high as the level that they claimed is optimal. So these are the areas where the giant sequoia regeneration is happening in spectacular fashion. You will not find regeneration like that fast, that dense, growing that quickly anywhere else except these larger high-intensity fire patches. It is really an extraordinary thing. And here's more epicormic branching. This is another large giant sequoia that would have appeared dead after the fire, but is not. And again, zooming in, you can see all that new growth, from epicormic branching. Now, that's all the good news. That's the wonderful stuff. There's also bad news, unfortunately, which is that these assumptions that the land management agencies are making, this narrative, is driving some very destructive policies, not just destructive legislation in Congress, that they're using this narrative about sequoias to push, Fix Our Forests Act, Save Our Sequoias Act. These are just logging bills under deceptive euphemisms. But they're also using emergency exemptions, the Forest Service and the Park Service, to do really destructive projects in the giant sequoia groves. This is in the Giant Sequoia National Monument on Sequoia National Forest. And this is what the Forest Service is calling restoration and reforestation in an area that burned in the Windy Complex fire in 2021. This is more so-called post-fire restoration and reforestation. And really what they're doing is, and they're not just removing, destroying a lot of habitat, removing important habitat features from the landscape like snags and down logs, which are really important for wildlife. They're not just removing most of the carbon from the forest. They are also destroying all or nearly all of the giant sequoia natural regeneration, because the logging machinery rolls over, crushes, and kills the natural sequoia regeneration. And that is a major, major concern. The point is that nature's got this covered. Nature is not needing our help here. There are places where nature does need our help. This is not one of them. We are actually not doing any help here, not doing any good. We're doing harm. This is more restoration and reforestation. And this is in the Freeman Creek Grove, and a portion of it where the Forest Service went in with machinery and cut down most of the small and medium-sized snags and is piling them for later burning, thinking that that's effective fuel reduction. It will not stop the next fire, but what it is doing is it's destroying a lot of habitat, and it's killing most of the sequoia regeneration. In the meantime, they're creating what look like giant bonfires on the landscape, and they're calling it fuel reduction. And this is being done with taxpayer money. And this is all because the Forest Service and the Park Service are so afraid of fire, particularly high intensity fire, that kills trees. But the reality is it's only a very small percentage of these, even the biggest fires. And it's some of the best habitat, some of the best wildlife habitat, some of the best sequoia regeneration that's out there. In fact, the best sequoia regeneration. And let's not forget, when you have a giant sequoia that's a live giant sequoia, that's a wonderful thing. It's great habitat. But when you have a giant sequoia snag killed by fire, that's also amazing habitat and carbon storage. Almost all of the carbon is still there. And it's a wildlife habitat for generations of cavity nesting species for decades and decades to come. You can see the cavity nests in this giant sequoia snag right here. You look at these giant sequoia snags in the field, and you will see large cavities, small cavities, raptors, woodpeckers, bluebirds. Fishers can den in these giant sequoia snags. Dozens and dozens of bird and small mammal species, and actually medium-sized mammal species can den in them. It's like an ecosystem unto itself, in a way, a large giant sequoia snag. So it's important to understand that that in a giant sequoia forest, as in many forest ecosystems, when a large tree dies, whether through drought or by fire, in many ways, its life is in the ecosystem, from a biodiversity standpoint, is just beginning. And last thing I'll cover here real quick before I'll wrap up and go to Q&A is this. Back to the hopeful aspect of this issue, which is, well, if you fast forward several decades, what does it mean? In these crown fire areas, what does a giant sequoia forest look like? Does it really regenerate and grow to maturity? Absolutely, yes, it does. They've been doing this for millennia, not just millennia, millions, tens of millions of years. This is a relationship with high intensity fire that goes back 90 million years with giant sequoias, literally to the time of the dinosaurs. And this is the Cherry Gap Grove here. This is a grove that burned in a large crown fire in 1955, one of the few fires that occurred during that century-long period when fire was almost entirely excluded from giant sequoia groves until the past decade. And in this area, naturally regenerated. This was an area that was not post-fire logged. This portion of it was not post-fire logged. It was not planted. This is all natural regeneration. And this is, it's 69 years post-fire in this large crown fire patch. Just for perspective, these are giant sequoias here. Almost all of them are giant sequoias. There's a few pine and incense cedar in there, but it's mostly giant sequoia. And the larger ones are between 3 and 5 feet in diameter at breast height. But a lot of them between 3.5 and 5 feet in diameter at breast height. They're well over 100 feet tall. And this is already a maturing giant sequoia forest. And again, that's good news. So, this is something that is, here's one here, this couple of research partners, Michael and Rob. And this is a giant sequoia here that regenerated after the 1955 McGee fire. And the great majority of these sequoias that regenerated after the McGee fire back in 1955 also survived the large rough fire that occurred in 2015. Most of the non-sequoias were killed. The sequoias were not, mostly. All right, so if you want more information on these issues, on fire ecology, check out our book, Mixed Severity Fires, Nature's Phoenix, and my book, Smokescreen, Debunking Wildfire Myths to Save Our Forests and Our Climate. And I am happy to take questions.